Today we're going to start chapter 14. Chapter 14 is on probability, and we will not finish chapter 14, but you're going to have 3 days on information on chapter 14. And so you'll actually be done with math at the end of this week, the 3 days of this week. And so today what we're going to do is we're going to talk about counting outcomes. And this information is good information to have. It's a lot of times used on standardized tests. And so we're going to spend a little time here. It's going to be a little different than the math that you've done before. The very first thing that we're going to talk about is let's say you flip a coin 3 times, okay? So coin is flipped 3 times. And I want to know all the possible ways that you can get heads and tails when you flip the coin. So what I'm going to do is I'm going to draw a tree diagram. So I flip the coin the first time. So this is flip number 1. I can either get heads or tails. Okay, that's the only outcome I can get when I flip the coin. Then I'm going to go on to flip number 2. Let's say I got heads the first time I flipped it. Then the second time I flip it, I can either get heads or I can get tails. Let's say I flip tails the first time. Well, then the second time I flip it, I can either get heads or I can get tails. All right, now I'm on to flip number 2, or flip 3. Let's say I did heads, heads. Now I can get heads or tails. If I did heads, tails, now I can get heads or tails. If I did tails the first time, heads the second time, the third time I can either get heads or tails. Tails, tails, I can either get heads or tails. Now, these give me all of the possible ways that I can flip this coin. Heads, 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 tails. Heads, tails, heads, heads, tails, tails, and so forth. If I count this last group over here, 1, 2, 3, 4, 5, 6, 7, 8, I know that there's 8 possible outcomes. There's 8 different ways that I can flip these 3 coins. Another way to get 8 is by recognizing that when I flip the coin the first time, there's 2 possible outcomes. When I flip it the second time, there's 2 possible outcomes. When I flip it the third time, there's 2 possible outcomes. So 2 times 2 times 2 is going to give me an 8. And that's called the counting principle. So let's do a different problem. That's the fundamental counting principle. Let's do something besides heads and tails. Let's say, I'm going to use something out of your book, okay? And this is example 2 on page 755, and it says, the Uptown Deli offers a lunch special in which you can choose a sandwich, a side dish, and a beverage. If there are 10 different sandwiches and 12 different side dishes and 7 different beverages to choose from, how many lunch specials how many different lunch specials can you order? Okay, so 10 sandwich choices, 12 side dishes, and 7 beverages. If I multiply those across, I find that I have 840 different combinations that I can have of the sandwich, the side, and the beverage. Okay? All right. So let's do one where I'm going to have you do, let's do a tree diagram. And you can pause the video and come back to the video and make sure you got it right. Okay, at a football game, a student's concession stand sells sandwiches on either white or rye. Okay, that's my bread choice. The sandwich can come with salami, turkey, or ham. And then you can choose chips, drinks, or chips, brownies, or fruit. Chips, brownies, and fruit. Okay, so I know that I have 2 times 3 times 3. So I'm going to have 18 different choices. Okay, so go ahead and draw your tree diagram and then come back and check it. I'm going to do mine up here while you're doing that. My first choice is white or rye. Then I'm going to choose one of those 3. I better spread them out so I have room. So salami, turkey, and ham. Same choice here, salami, turkey, and ham. Then I'm going to make that choice, and I'll just use the initials. Chips, brownies, fruit. Chips, brownies, fruit. Chips, brownie, fruit. I'm running out of space here. Chips, brownies, fruit. Chips, brownies, fruit. And chips, brownies, fruit. And if you count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are all your different arrangements that you can make with those choices. All right, that's the fundamental counting principle. Let's look at these. Okay, sometimes there's arrangements that can be made. These are just choices, but sometimes there's actual arrangements that take place that are going to change your count of possible ways that you can set up something. Let's say you go into a movie theater. 5 people go into a movie theater and there's 5 chairs. Well, in this sense, there is order here. It's important. Let's say the chair is making the choice between the 5 people. So the first chair can choose any of the 5 people to sit in it. Well, once a person sits in that chair, there's only 4 left that the chair can choose from for the next one. Then there's 3 possibilities that can sit in that chair. There's 2 possibilities and then 1, because the person sits, the person sits, the person sits, the person sits, and then the last person sits. Okay, so to find out the different ways that you can arrange people in these chairs, you would go 5 times 4 times 3 times 2 times 1. It's an arrangement. You may use your calculator on this chapter, okay? So if I multiply this out, I have 5 times 4 times 3 times 2 times 1, which is 120 different ways that these people can sit in this chair. This is also called 5 factorial. 5 factorial is the same as saying 5 times 4 times 3 times 2 times 1. If I said 3 factorial, then that's equal to 3 times 2 times 1, or 6. Let's do, okay, here we go. Okay, this is example number 3 in your book. It says, Mackenzie is setting up a display of the 10 most popular video games from the previous week. If she places the games side by side on the shelf, in how many different ways can she arrange them? Okay, I have 10 video games, okay, and I'm going to put them on a shelf. So there's an arrangement here. And I want to know how many different ways she can arrange them. So I can make lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She chooses from 10. She places it there. She's left with 9. Then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. That's the same as 10 factorial. Now I'm going to multiply those all out. Like I said, make sure you use your calculator on that. And you are going to find that it gives you an answer of 3,628,800. All right. Let me give you one to try, and then you come back to the video and make sure you got it right. All right. There are 8 students in an algebra club at Central High School. The students want to stand in line for the yearbook. How many ways could 8 students stand in line? Okay, there's 8 students, they want to stand in line. So do that problem and then come back to the video. So you have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or what we call 8 factorial, which is equal to, if you use your calculator, 40,320 different ways that they can stand in line. All right. All right. Here's one more to do. Okay. Zach and Kurt are going to an amusement park. They cannot decide in which order to ride the 12 roller coasters. Okay, so how many different ways, now again, use your calculator, can they ride the 12 roller coasters? So I have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or this is also 12 factorial. Like I said, you wouldn't want to do this without a calculator. All right, it's 479,1,600. But let's say I changed the problem and I said, if they only have time to ride 8 rides, okay, then how many different ways can they do it? Well, here are my 8 rides. So I still have 12 choices for my first ride. Once I've ridden that one, now I'm down to 11 choices, 10 choices, 9 choices, 8 choices, 7 choices, 6 choices, and 5 choices, because I'm only riding 8. So this part right here is not included in that. And then it changes to 19,958, or 19,958,400. Okay? This is what your homework's going to be about. Okay? Drawing tree diagrams, coming up with a whole number of ways that you can arrange things. Sometimes it's just choices. And so that's the counting principle. Let's say you have 4 pair of shorts and 3 tops. How many different ways can you wear them? 4 times 3 is 12. It has nothing to do with order. It has nothing to do with arrangement. This part has to do with arrangement or order. People are standing in line. They're making a choice of chairs. Okay, there's order here. If it has to do with order, you're talking about this part. If it has to do with just choices, you're talking about that part. So your homework is on page, let's see, 756 through 757, 4 through 17 all.